Okay, primary trig ratios. We have three major ratios. You guys have learned them before. We have sine theta being our angle is equal to the opposite side of a right angle triangle divided by the hypotenuse of a right angle triangle. Cosine theta, or cosine the angle, is equal to the adjacent side of a right angle triangle divided by the opposite. And finally, tan theta is equal to the opposite side divided by the adjacent. These only work with what type of triangle? Right angle triangle. We can only use these with a right angle triangle. Okay? Just to recap, in case you do not know what the hypotenuse is always opposite of the right angle. Okay? Now, these other two parts, we'll move on down the page. Thanks. Okay. As we move down the page, the opposite and adjacent angles are actually completely in reference to something. And what I mean by that is they're in reference to whatever angle we're deciding to work with. So, for instance, if I'm working with this angle, we're going to call these the exact two are the same. We'll call one x and the other theta. Okay? In this case, the hypotenuse, which we'll denote by h, will always be the same. There'll be no difference. H will always be the longest side of the right angle triangle. But in reference to the angle, the opposite and adjacent sides will change. Okay? So again, these are both the exact same triangle, let's say. If we're talking about angle x, what would be considered the opposite side of it? Anyone know? Which of these legs? The bottom one. The bottom is considered opposite of this angle. It doesn't touch that angle in any way, therefore it's the opposite of that angle. So in this case, we would call that the opposite side. Every angle is also going to be having, or is going to have, two sides that touch it. Okay? Adjacent means to be touching something, but one of them will already be denoted as the hypotenuse. So by deduction, the other side has to be what? The adjacent. Okay? So that means this side here is considered the adjacent. We'll call it ADJ. We're going to have that line. Okay? We're going to get to that, depending on what angle we're working with. So, in the exact same triangle, if we're trying to solve for the other angle, is this still considered the opposite side to this angle? No. That's changed over here. So this now becomes the opposite side of the triangle. Okay. And again, by deduction, hypotenuse is touching it. The other side that's touching that angle is the adjacent. Thank you. Okay. With that being said, we're going to practice setting up the ratios also. We'll take a right angle triangle again. This time we'll give it some measurements. Now these measurements may not be exact. We'll say 3, 4, and 5 of this right angle triangle. Okay. So let's say again, this is the triangle from above, and we're trying to find angle x. If I have those three measurements, I can set up any three of the ratios to solve x. I just have to set them up in different ways. For instance, sine x, that's solving that angle, is equal to the opposite. Well, the opposite would be considered 4 over the hypotenuse, which is 5. I could also use cosine x, which would be the adjacent. The adjacent in this case is 3 over the hypotenuse, which is 5. And finally, I could still solve for that same x using tan, because of the amount of information we have. And that would be the opposite, which is 4, over the adjacent, which is 3. All three of these cases would help us solve for angle x. Okay? Now, technically, to solve for x, we have to get x by itself. In other words, I have to move either sine, cos, or tan to the other side of the equation. Does anyone know what they become when we move them to the other side of the equation? When we isolate the x? Or when we're solving for an angle. The specific button on your calculator. Yeah, you gotta hit second function, and you're gonna get what's considered the inverse. Okay? So, in order to solve this x, we'll do it in red. X would then be equal to sine inverse of 4 over 5. Or if we're looking for x here, we'd be looking at cos inverse. It's supposed to be to the -1. I don't know why the computer's doing that. And finally, x over here would be considered tan Good, it did it. Thank you. 4 over 3. Okay, so let's actually test this out and see if we can figure out what the angle x is going to be. Do I have a calculator on here?
Yeah.
Okay, so we have a calculator up here. We're going to find sine inverse. Oh, geez, how do we... There we go. So, sine inverse, it may come up looking like something like that on your calculator, that's fine, of 4 divided by 5 is equal to...
What on earth is arc?
That is not even correct. Okay, our problem, which is a good learning point, is we were in radians. So we changed it to degrees. Inverse of sine is 4 divided by 5. We get 53. Okay? What we're going to do is test the other two, cos and tan, with the exact same stuff. So we're going to invert cos of 3 divided by 5, 53. We got the exact same measurement. And when we do tan, inverse of 4 divided by 3, we got 53 again. So it didn't matter which of the ratios we used, we still got the same measurement in terms of an angle. Okay? Yes, it will have to be the same. And then we could do the exact same thing for our theta angle, just our ratios be written differently. Okay? So we can use these to solve sides or angles of a triangle.